Nearly 3 billion miles from the sun, a blue world drifts through almost total darkness. From a distance, Neptune looks serene, a perfect sphere of deep sapphire glowing faintly against the black. It is the kind of beauty that makes you trust what you see. That trust is a mistake.
Neptune is not the quiet, frozen world we were taught about in school. It is a machine of violence wrapped in the most beautiful color in the solar system. And what hides beneath those blue clouds is so extreme, so hostile, so fundamentally wrong, that it rewrites what we thought a planet could be. The first real clue came in 1989, when Voyager 2 became the only spacecraft to ever visit Neptune. What it found made no sense. Neptune receives roughly 1/900th of the sunlight that reaches Earth. By all logic, it should be dead, a frozen, inert ball at the edge of the solar system. Instead, Voyager measured winds screaming across the atmosphere at over 1,200 miles per hour, the fastest winds ever recorded on any planet, faster than the speed of sound on Earth. If you were floating above Neptune's cloud tops, you would not hear those winds. You would feel them. A wall of hydrogen and helium moving fast enough to strip metal from a spacecraft hull. No storm on Earth, no hurricane, no cyclone, no tornado comes close to this. So where does that energy come from? The sun cannot explain it. Neptune is too far away, too starved of solar radiation to power anything close to this violence. The answer, scientists believe, comes from deep within. Neptune radiates roughly 2.5 times more energy than it receives from the sun. Something inside this planet is generating enormous heat, and after decades of study, no one fully understands what drives it. Now imagine sinking below those sapphire clouds. At first, you see blue in every direction, a deep, infinite blue that looks almost peaceful. Then the light fades. The atmosphere thickens into a crushing, darkening fog of hydrogen, helium, and methane. There is no surface to land on, just gas becoming denser, hotter, heavier. Temperatures climb past what any human-made material can survive. Pressure builds, 10,000 times what you feel standing at sea level on Earth, then 100,000 times, then more. You would be compressed to nothing long before reaching what lies beneath. And what lies beneath is where Neptune becomes truly alien. At a depth of roughly 6,000 miles, pressure does something extraordinary to carbon. The same element found in pencil graphite, in coal, in the cells of your own body, is squeezed so violently that its atomic structure collapses and reorganizes. It crystallizes. It becomes diamond, not microscopic particles, solid chunks, possibly as large as boulders, falling like heavy rain through a superheated ocean of water, ammonia, and methane compressed into a bizarre, electrically conductive fluid. How do we know this is real? In 2017, researchers at the SLAC National Accelerator Laboratory recreated these extreme conditions using high-powered lasers. They watched carbon transform into diamond in real time. On Neptune, this process may have been happening continuously for over 4 billion years. Deep inside this planet, there could be an entire mantle of solid diamond, thousands of miles thick, slowly accumulating around the core. But Neptune does not keep its chaos hidden. In 1989, Voyager 2 photographed an enormous vortex in Neptune's southern hemisphere, the Great Dark Spot. It was roughly the size of Earth, a storm of unimaginable power, spinning counterclockwise at the edge of the upper atmosphere. 5 years later, when Hubble turned its lens toward Neptune, the storm was gone, vanished. No remnant, no trace, no debris. Then new dark spots appeared in different locations, and those disappeared too. Neptune conjures planet-sized storms from nothing, sustains them for a few years, and erases them as if they never existed. No one has explained why. And then there is Triton. Neptune's largest moon should not exist where it is. Triton orbits Neptune backward, the only large moon in the entire solar system with a retrograde orbit. This means Triton was not born alongside its planet. It was captured, most likely a Kuiper Belt object that wandered too close and was seized by Neptune's gravity billions of years ago, and its fate is sealed. That backward orbit generates tidal friction that is slowly pulling Triton closer. In roughly 3.5 billion years, it will cross Neptune's Roche limit, the invisible boundary where gravitational stress exceeds the moon's own structural cohesion. Triton will not crash into Neptune. It will be torn apart, stretched and shattered into a vast ring of frozen debris encircling the planet that captured it. Neptune will wear the remains of Triton the way Saturn wears its rings, a monument made from something it destroyed. Until that day, Triton remains one of the strangest worlds we have ever seen. Voyager 2 photographed active geysers on its surface, plumes of nitrogen gas erupting 5 miles high through the thin atmosphere. If you stood on Triton's frozen plains, you would see dark streaks painted across the ice where those plumes had fallen back to the surface. A frozen moon, nearly 3 billion miles from the sun, actively venting, actively changing. The same tidal forces that are killing Triton may be the very thing keeping it alive. And just when scientists thought Neptune had revealed its last surprise, it delivered another. Between 2003 and 2018, a team of researchers analyzing thermal infrared data from some of the most powerful ground-based telescopes on Earth made an unexpected discovery. Neptune's stratosphere, already brutally cold, had dropped by approximately 14 degrees Fahrenheit. On a planet already averaging minus 364 degrees, something in the upper atmosphere was changing, and no existing model predicted it. Seasonal cycles do not explain it. Solar variations do not match. The James Webb Space Telescope has since turned its infrared instruments toward Neptune, revealing the planet's ring system and atmospheric layers in unprecedented detail. But the cooling mystery remains open. Neptune is changing in ways we cannot yet explain. What happens when the most distant planet in our solar system starts behaving in ways no theory can predict? This is what makes Neptune terrifying. Not the cold, not the distance, the fact that it should be dead. And instead, it is one of the most violent, most active, most unpredictable worlds in our solar system. A world where it rains diamonds into oceans that should not exist. A world that captures moons and drags them toward destruction across billions of years. A world that builds storms the size of Earth and erases them without a trace. A world that defies its own models and cools when nothing says it should. Neptune sits at the boundary between our solar system and the void between stars. And the last thing you encounter before that emptiness is not silence. It is a storm that no one can explain.